Hi, I'm Dr. Renault, and I'll be taking you through BUIS 2400, Topic 1, Video A. What is a data model? This video will follow along with Chapter 1 of Data Modeling Made Simple by Hoberman. This chapter is really all about a few definitions. Um, and I've got a little bit of extra information in this presentation that's not in the book, but the definitions that you need to learn are the idea or the definition of a map or a model. And I like to think of a map or a model as a simplification of the world to describe complexity. It's not as complex as the world is, but it kind of distills the world down to something that you can understand to help describe what it does. Wayfinding is and I use map and model interchangeably. Wayfinding, because what is a map but a two-dimensional piece of paper model like the one hanging on my wall behind me? Wayfinding is the process of using a map or a model or a tool to find one's way from one place to another. Wayfinding. Um, if somebody gave you a printed out list and said, go to here, turn at this street sign, go to here, turn at this building, go to here, turn at this landmark, well, that would be wayfinding, wouldn't it? It's another map or a model. It's another type of simplification, but it's a very specific simplification because it's a simplification of how to get from one place to another. Now, every model includes something called its abstraction level, from a very high level model to a very low level model. Let me describe some models to you, and let's think about the abstraction level. How many of you have ever been to the hobby store and bought a little box full of plastic parts of a plastic model? You can go to the hobby store and buy a model car, and it comes in a cardboard box with 30 or 40 little pieces, and you take those pieces and you paint each one of them and you glue them together and you follow the directions, and what you're left with is a car, kind of like this. This is a model of a tractor. It's an abstraction because it's not actually a tractor. You can't ride on it. You can't till. The motor doesn't actually turn or do anything, but the wheels turn, and it's kind of fun to drive around on the carpet. Um, but by looking at this, you can gain an understanding of what a tractor is. If somebody says, well, a tractor is used to pull a plow, okay, and you look at the tractor and you go, well, why are there big wheels? Oh, the big wheels help keep it from getting caught in the dirt. Oh, um, and there's the seat for the man to sit on, and there's the steering wheel. Oops, my model has the steering wheel broken off, but you can kind of get the idea. And the engine, it goes here. This isn't an engine, there are no parts, nothing moves, but you get the idea of the model. This is a very high level abstraction, a very simple model of a tractor. If I were to build a low level model of a tractor, might I build a tractor, this big, and actually put a motor that really works, and it would actually start up and go by itself? Or wouldn't that be a more complex model, or what we call a lower level of abstraction? It's not as abstract of a model. So think about a model airplane. The balsa wood airplane you pick up at the dollar store, that's just a little piece of wood and a little piece of wood and a propeller and rubber band, and that's it. Does it fly? Yes. Does it represent a model airplane? Does it represent an airplane? Yeah. You get the idea of wings and propellers and propulsion and all of that, and you're going, that's interesting. Then you build the plastic model airplane, and you then build a flying model airplane that's remote control, and each one of these are getting more and more complex until we can actually build a miniature airplane the size of a building or size of a room, and then put that in a wind tunnel and test things that we couldn't test, and actually have wings that move with flaps and ailerons and all those things on the wings. And you can see the abstraction is different. So each model has a different purpose. It's trying to describe a different level of complexity and a different type of complexity. Think about the map I have here behind me is a map of the world, but instead of Instead of, well, countries are marked, but they're marked by regions of ham radio license numbers. That's a weird model. But for me, who wants to know where somebody's from, that model is really helpful. But you couldn't navigate around the world using this model. You would need a much more complex model or a different kind of model. Think of the roadmap. Think of the atlas. Think of those types of maps and models. So be sure you think about the abstraction level. We'll talk about abstraction of data models as we move into subsequent lectures. Three more definitions I really want to stress, and I need to hear you all semester in everything you write, and I need you to get these three words in your head to understand what they mean. The three words are data, information, and knowledge, and they're all very related to each other. One is created from the other, is created from the other. Let's define data. Data are the raw facts that a business generates. Think about every time the cash register goes beep when you run an item across it. Well, there's data created because that barcode was read, the price was looked up, and it was added to a ticket, right? So there's data, transactional data, lots of details, lots of details. Think about the transactional data that goes on inside of any system, any kind of business system. Think of all the transactional data. Every time you go to a website, it keeps a log of where you come from, of dates and times. On a busy website, there could be thousands and hundreds of thousands of entries in that data stream, in that pile of data. So it's the raw facts, the transactions, and there's a huge quantity of them. Some businesses generate gigabytes and terabytes of data every single day. Think about a large grocery store chain or a department store chain, or think about the Internal Revenue Service, the federal government. Think about airlines with all the passengers and tickets and all of that. Even think about the university, of the data of every time you swipe your meal card, there's data created. Every time you register or drop for a class, there's data created. Every time a class is created or deleted, data is created. So think of all the data that's being created. Can one human being understand the data flow? No. There's no way that a human can understand all of that data. And what we do is, from that data, we create something called information. Information are reports and usable summaries of data. They're understandable and they're derived from data. So, for instance, you're working for a grocery store chain. Let's just throw that out as an idea. Maybe you're the buyer for peanut butter. You're in charge of making sure all of the stores have all the peanut butter they need. Is there somebody with that job? Yes, actually there is. So the peanut butter buyer is in charge of buying peanut butter and making sure that we have enough in all the stores. The buyer doesn't care about each and every time the cash register goes beep, but the buyer does need to know how many jars of Skippy Creamy, how many jars of Skippy Crunchy, how many jars of Skippy Crunchy Natural we've sold in our region in the last day, in the last week, in the last month, in the last quarter. Wouldn't they need to know that? Because then they know, and they need to know how many jars there are in the warehouse of each, and they need to know how many jars there are in the stores of each, and they need to kind of have an idea of when the warehouse is going to ship it, but they don't need to know the details. They just need to know that we have a 10-day supply in the warehouse, or we have a 22-day supply in the warehouse, and the stores have this many days of supply. You can see how we could generate all of that data, all of that information, from that data. You can see how we could take all of those data points, all that transaction of when we ship, of when we receive, of when we transfer, of when we put on the shelves, of when we sell all of those items. We can summarize all that into reports, into meaningful summaries, and that buyer of peanut butter can make smart decisions. The buyer can create knowledge. Knowledge is when we internalize that information, when we bring that information from the outside world, from our report, into ourselves. Now, as a database person, as a data person, we need to understand what knowledge is wanted. We need to understand the information that we need to generate to be able to give the users that knowledge. And we also need to be able to find all of the transactional data and record and save all of that transactional data so that we can slice it and dice it. We can summarize it, we can massage it, we can collect it, we can manipulate it to create all of that fabulous information that gives us the business knowledge to be able to make the right decisions for our company and our business and our future and everyone. So now that we've defined what data is, and now that we've defined what a model is, what is a data model? Let's just kind of put those words together. A data model is a set of symbols and text which precisely explain, and that in quotes came from the book, a set of symbols and text which precisely explain the data from a business or other perspective. So, whatever the perspective is, whether we're doing this database for a business purpose or for a scientific purpose or for a research purpose or whatever, it's still a business. It's still an entity. It's still a activity. So, uh, that's what a data model is. We're modeling data. There are lots of different formats of data models, from the crow's foot diagram, which I'm going to focus on in this class, to the Chen model, which is another model of a diagram of data models. There's a data model called the UML, the Unified Modeling Language model, and there are lots of different types of data models, but the most important thing is that we understand how to use one of them well, and are able to communicate, because once we understand one of them well, we'll be able to follow up and read other kinds of models. If you know how to use one kind of map to get around, if it's a different type of map, your learning curve is pretty short. It might take a little while, but it won't take you long to figure it out. So we define what a data model is. A data model, though, really must contain these three things. A data model needs to contain these three things. A data model needs to contain or have these three attributes. A data model can contain only types. Okay? A data model doesn't contain specific values. For instance, this tractor doesn't actually have on the tire here what size the tire is. It just that it's a tire. It doesn't have printed on the side of the tire what the size of the tire is. The actual data value that goes along with this tire isn't here. It just says it's a tire. So a data model contains only types. And we'll see that it doesn't contain the actual values. It contains the concepts. For instance, what if I had a database, a data model for students? It would contain a field or a type that says, well, there's a type of data called a student number. That's a type of data. We can describe the type of data. It's a number between this number and that number. It has this many digits. It contains only numbers. Okay, student number. That's a type. The number 1, 2, 3, 4, 5, 6, 7 would not be a type. It would be an actual data value. See the difference? So a data model contains only the types of data, not the actual values, the types. It contains the interactions between data values. And you're like, Interactions. Yeah, well, let's again think of the student model, a student and a student's classes, a student's schedule. There's a relationship between a student and a class, isn't there? Yeah, there is. Think a student can have zero or more classes, but a class can have zero or more students enrolled. So a student enrolls in classes and a class is enrolled in by students. So there's a relationship between those bits of data. There's a interaction between them. So a data model contains only types. It contains the interactions between those types or relationships and provides a concise communication method. It's got to be simple and it contains a lot of information about the system. It contains a lot of information about how everything relates. Think of all the data points that, like I say, a large national grocery store chain would collect from locations within the store, shelf numbers, row numbers, to purchase orders, to a purchase, to receiving goods in a warehouse, to putting goods in a warehouse away, to creating an order to ship it to the store, to shipping it to the store, to delivering it to the store, to receiving it in the store, to putting it on a shelf in the store, to checking it out of a store, to and think of all of those, each of those types of transactions then contain all the data points, all the data bits, all the data things that go along with that transaction. So a data model, and this is a question you'll see in the homework and you'll probably see on a quiz. A data model contains three things: types, only, interactions, and it's concise. And the four words or three I want to hear are data types, interactions, concise. And I'll be groovy if you just parrot that back to me. What are the three big parts of a data model? This concludes BUIS 2400 Topic 1 Video A, What is a Data Model? I'm James M. Renault, PhD. I'd like to thank you for watching, and remember, this video is copyright 2020 by James M. Renault, PhD. All rights are reserved.